Okay, in this set of problems, we're just going to apply the second fundamental theorem of calculus, which says that the derivative of an integral defined function from any constant to the variable x of any function written as a function of t is just f of x. We simply take the integrand and plug in the x value. That's as easy as it is, with one catch. Now, that one catch will show up in these problems when we get to numbers 89 and 91. And that is when what we're plugging in is no longer just a variable x. It's a function of x. And when it's a function of x, we're going to view that as a function composition, and we're going to need to use the chain rule for that. So I'm going to quickly go through these examples. And 81, all we're looking for, f prime of x, is simply plug in x wherever you see t, and so f prime of x is simply x squared minus 2x. Done. 83. Plugging in x, again we're going to get f prime of x, and we showed why this works the way it does in the previous set of problems, but we can just use the fact that this is a property of integrals and simply apply the rule here. So this is going to be x to the fourth minus 1, I'm sorry, plus 1. And number 85, f prime of x. You don't need to take the derivative of that. This is a rule for finding the derivative of an integral defined function. Just like finding the derivative of sine is cosine. It has its rule. The derivative of x squared is 2x. They all have their rules for how to find their derivatives. Well, how do we find the derivative of an integral defined function? We simply plug that upper limit, that variable, in to the integrand for t, and we're done. So number 85 is simply x times the cosine of x. We don't need a plus c or anything like that. These are derivatives here. Now, as I said with number 89 and 91, we're going to have a slightly modified case. So first we are going to plug in, so f prime of x, we're going to take our upper limit, which is sine of x, plug it in for t. But after that, because this is a chain rule where sine of x is the inside function, after we take the derivative of the outside, which is simply plugging in the upper limit, we're going to multiply that by the derivatives of sine, which is cosine of x. And now we're done with that. Again, to make this clear, I'm going to do number 90 as well. We're going to take the x squared and plug it in for t. So it now becomes f prime of x now becomes 1 over x squared to the third times the derivative of x squared, which is 2x. We're going to get a 2x in the numerator and x to the sixth in the denominator, or 2 over x to the fifth. Number 91. We're going to plug in, that's x cubed for t. So f prime of x is sine of x to the third raised to the second times the derivative of that upper limit. That's going to be 3x squared, and so we end up with 3x squared times the sine of x to the sixth power. And that's number 91. I'll do number 92 as well. So hopefully that makes sense. So we're going to take the upper limit, which is x squared. We're going to plug it in for theta. Theta is just a dummy variable there. And so we're going to get sine of x squared quantity squared. So sine of x squared quantity squared times the derivative of the upper limit, which is 2x. We end up with 2x times sine of x to the fourth power. And so again, that's how these work. And we'll stop this video at this point.